Hello. Should see my desktop now. Is anybody there? Let's see. Oh, got a few people here. Hello. Can you hear me? Do you see the desktop? Does everything seem okay?
Yeah,
Okay,
yeah.
great. Thank you. Okay. All right, let's see. Oh, most people are here now. Okay. Okay, so here's what we're going to do today. The main thing right now is your first homework assignment is up there now. So we'll start off by talking a little bit about the homework assignment. So you click on here, and this page describes the homework assignment. So it's a lot to read. It's actually not going to be a lot of code. When you're done writing the program, it's only about a page of code, but there's a lot of ideas to explain. So there's a lot, you have to read all this the explanation pretty carefully. So there's a zip file that contains the starting code for the assignment and the testing code. So just click on that link, and that downloaded the zip file, and I'm going to unzip it. Okay, so let's start by looking at what's in the zip file, and I'll explain a little bit about the homework assignment as we go along. Okay, you're supposed to write a program called filter.c. So you're going to write this program here, and if you open that program right now, it's just an empty C file. So you'll write your code in here. So you'll be writing the code in that file. Okay, and there's a demo version of this program right here. Okay, so this shows you what the program does. What the program does is it reads in a jumble of numbers like this. This is called a stream of numbers. So this is what it is. It's some spaces followed by a number, followed by a random amount of spaces, followed by a number, then a random amount of spaces, a number, a random amount of spaces, a number, and this just continues on. Random amount of spaces, number, random amount of spaces, number. So we thought of that as stream of numbers. And your program has to take that stream of numbers and reformat it into a nice output stream of numbers in columns and little tables. Okay. So your program takes in this jumble of numbers. You can see that these numbers are in the same order. They've just been reorganized into a nice format. The main thing about your program is it has parameters that determine how it formats. For example, this has got 1, 2, 3, 4, 5, 6, 7, 8 columns. That's one of the parameters of the program, how many columns there should be in the output. In this output, the numbers are spaced apart by a certain amount. Okay, and that's another parameter. How much to space the numbers apart, how much space between the columns is another parameter. And then the third parameter is these numbers get grouped together. Like that's the first 14 numbers. Okay, so the first 14 numbers get grouped together into columns of 1, 2, 3, 4, 5, 6, 7, 8. And then there's a blank line, and then there's the next group of 14 numbers. Okay, so notice that these input numbers got grouped into groups of 14, and then they get formatted into a little table of 14. Okay, so the parameters of the program are how many columns, how much space between the columns, and how many numbers are in a little subtable before there's a blank line. So there's 3 parameters that this program takes. Okay, so that's the code you're going to write is going to be a program that takes in these numbers, gets its 3 parameters from different places. The parameters are going to come from different places. And what we'll see, talk in a minute about where the parameters come from. And then the program will format the numbers according to the parameters. Okay. Now, what makes this assignment tricky, not really hard, is that you're going to be using a lot of ideas that you've probably not seen or used before. And they're listed up here in the first paragraph. Okay, you're going to be working with command line arguments, environment variables, and standard input and standard output. Okay, so these are ideas that we're going to be talking about today. What's a command line argument? What's an environment variable? What's standard input and standard output? Okay, now let me show you To test your program when it's done, there's a file in here called source. And if you compile it, I'm just going to compile it. If you run source, it generates a bunch of numbers. That's the source for the pool of numbers. Now notice when I double click it, sometimes it just runs and pops up, but that's not very convenient. So I'm going to open a command line here, and I'm going to run source. See, that's its out. Source produces a stream of numbers. Okay, and source produces a stream of numbers. Now, it looks like it's putting the numbers in the console window, and that's actually kind of not really accurate. If you look at this program, if you look at the source code to it, when it produces numbers, it prints them. See, there it's printing spaces. See, there's where it prints the number. Okay, there's where it's printing a number. So when you print, you think, okay, things end up on the console window. This program prints a bunch of numbers to the console window. But here's one of the first ideas that we're going to learn in this assignment. That's not what printf does. Printf does not send things to the console window. It sends things to what's called standard output. Okay, and this is a real important idea, and this homework assignment is going to be based a lot on understanding some of these subtle things about operating systems and how things really work. This program, this printf, sends things to standard out. And here's what I can do. When I run source, I can tell Windows, send source to standard out to the file temp.txt. Now I run source. Look, nothing happened. I didn't see any output. What happened is the printfs in this program were redirected to this file temp.txt. Printf didn't know it was talking to a file there. That's called I/O redirection. And this is one of the key ideas in modern uses of operating systems. This is how you this is a big part of how you build large systems of programs. Is programs send their output to files and send their output. We'll see in a minute that a program can send its output to another program. Okay, so if I run the program, if I run source like this, printf defaults to sending things to the console window. But if I run the program like this, then I'm telling the operating system, make the printf of source tied to this file, and I can make it tied to a different file this time. Okay, notice that the file got created over here. Okay, if you watch over here, I'll do it again. I'll do a third file. See, a file got created again. So now that the third one got created. Okay, if I open this file here in an editor, then I run this program and send the data to that file again. Here's what's interesting. What Windows just did is it deleted the previous version of temp1. And let's see, did I? Oh, I opened the wrong file. I'm sorry, I opened the wrong file. Let me. Open temp1. Okay, there's temp1. There's what's in it right now. Run this again. Okay, what Windows just did was it deleted what was in temp1 and wrote a whole bunch of more data to temp1. If I click on this editor window, notice that the editor's got a little pop-up saying, what's in this file is changed. Do you want me to reload it? And I say yes, and there's the new numbers. Okay, there's the new numbers that are in this file. Okay, so the editor is open, the file is open in the editor. I can see the file over here. Every time I run this, new data gets sent to that file. When I switch over to the editor pops up saying, should I reload the file that's got new data in it? And I just click yes, and there's the new data. Okay, this is called I/O redirection. See, that the little greater than symbol says, run this program, but send its printfs to that file there. Okay. All right. Now, here's the demo version of the program you're going to write. It's this thing, filter demo. What does filter demo do? Okay. Filter demo what filter demo does is it reads from standard input. Standard input is the keyboard. So if I type a bunch of numbers here, and I hit enter, they get formatted to standard output. So filter demo is reading from standard input, which by default is the keyboard, and it's writing to standard output, which by default is the console window. Now I can type some more numbers, hit enter, and those numbers got formatted. I can type another number, and they're getting formatted. Looks kind of messy because my input and my output are all mixed together on this console window, which is really not convenient. But right now, my input and my output are both being, see, every time I type something, it shows up on the console window, but then it actually gets echoed out by the program too when I hit enter. So as I'm typing, I see what I'm typing. When I hit enter, the program reads what I typed and it produces its output. So the input I typed is still sitting here, and the output that the program produced is sitting here. So it looks kind of messy. Okay. So the program, this is what we call a filter program. Read from read from standard input, which by default is the keyboard, write to standard output, which by default is the console window. Okay. Now I can do, now Control Z tells this program that there's no more data. Okay. Now let me run this program and send its output to temp2.txt. Now I type a bunch of numbers. Okay. Oh, notice that the temp2 file got created. It's going to hold the outputs. I hit enter. Well, where did the output go? It's not yet in, it will eventually end up in temp2, but it's not there yet. But the temp2 file is ready to hold the output. As I type numbers, they're being formatted. Right now, they're actually in a buffer. Right now, all the output numbers are in a buffer that Windows holds. When I type Control Z, Windows will send that buffer to my file. There's the output. Okay, there's the input I typed. Now the output, see, I used O redirection. So the output came in over here. Okay, now you can also redirect the input. Okay, right now I have a bunch of data in temp1. There's a bunch of random data. Okay, I can tell filter demo to take its input from, now this is, I'm redirecting the input, take its filter from temp1.txt. Now I'm saying, I'm running this filter program. Normally it takes its input from the keyboard, but because of this little symbol here, I told Windows, replace the keyboard with this file. So now when this program runs, it doesn't see the keyboard anymore. It sees the input it sees what's in that file. Okay. And then that's what it's going to format and send to standard output. Okay. If you look, that output, see, it came from there. See, the first number is 1486, the next number is 7646. So those numbers were this stuff formatted. So I ran this program with its input coming from that file. Okay. And if I want, I can do the following. I can say, take your input from that file and send the output to, the program is going to filter my data. It's going to take the data in this file, run it through this program, and send the result to this file. This is what we mean by a filter. It's going to essentially filter this stuff through this program to this output file. This is why we call these filters, because we think of it as the data in temp1 passes through the filter demo program, and then the filtered data goes to temp5. So I hit enter. I don't see any output here. I don't type any input. I don't see any output, but temp5 showed up over here, and there's the formatted version of temp1. There's the input data, and there's the formatted output data. This is how big data pipelines work in the real world. This is how data gets processed. Yeah, right here, my data is just a few hundred numbers. You have to imagine large computing systems processing billions and billions of numbers at a time. This is done quite often in this kind of way, what we call data pipelines. You filter data through one program, then another program, then another program. Okay, now here's another way I can run this. Okay, remember, source generates data. Filter processes the data. I want to do the following. I want to take the output data from source. This symbol here is called a pipe. You imagine it's like a pipeline that's connecting the output of source to the input of filter demo. Okay, so what that does is that generated a bunch of data that came out of source, passed the data into filter, but filter wasn't told where to send its data to, so filter sent its data to the console window. So filter filtered the data that came out of the source. This is called a pipeline. Okay, that pipeline, the output of one program got fed directly into the input of another program. Okay, and then if I want, I could take the output of the filter and I could send it to another temp file. So this generates a bunch of data, sends it to the filter program. The output of the filter program gets saved in temp 6 now. Okay, and there's the filtered output. Okay, so this is the kind of thing that this programming assignment's about, is you getting used to these ideas of how to work. I give you the source program. It's mainly there for you to test your filter program. The source instead of running your filter program and typing in a bunch of numbers to test it, when you're working on it and you want to test it, it'll be a lot easier to test it by saying, generate some source data and send it to my filter program. Okay, except right now the filter program doesn't work, so I use the demo. Okay, so then I could test how the filter program is working. Okay, now here's some more things about the command line. I told you that the filter program takes 3 parameters: how many columns there are, how much space there is between the columns, and how many numbers to make into a group. Okay, right now the program's using its default values. It defaults to 1, 2, 3, 4, 5, 6 columns. It defaults to each column being 5 characters wide. If you notice that it's a little bit, if I click here and well, you can't really, that's 5 characters. And then the next column is 5 more characters. Then the next column is, so each column is 5 characters wide, including there's the 4 digits that make up a number, and then there's the space. So a column is 5 digits wide. Okay. I'm going to run filter demo. Oops, I typed that wrong. I'm going to run filter demo, and I'm going to tell it, make the columns 7 digits wide. The first command, this is a command line argument to the filter program. And it's saying that I want to change the way the program behaves. I want the columns to be 7 characters wide. Now, if you look here, the columns now have to scroll back up. A column is, you can count them, there's 7 digits. There's 7 space characters in a column. In this case, 4 digits of numbers and 3 spaces. So there's 7 digits in a column. The columns are 7 digits wide. Okay. I can also run the program. I can make the columns 12 digits wide. Okay. Right. I can also say how here now here I'll make the columns 5 digits wide, and then then here's I can say how many columns there are. I'm going to give 3 columns. Okay, So this said, make the columns 5 digits wide. This said, use 3 columns. So 1, 2, 3 columns. Okay. Here's columns that are 7 digits wide, but there's 3 of them. Okay. The groups are still 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers in a group. The default group is 10 numbers. There's a third command line argument. I'll make the group 15 numbers. Okay, now if you check, there's 15 numbers in each one of these groups. So now the program had command line arguments. Columns are 7 characters wide. There's 3 columns, and I group the numbers in groups of 15. So I have 15 numbers in each group with a blank line between the groups. Okay, so the program takes command line arguments. The source program also takes command line arguments. If you run source, it generates a random amount of data. You can tell source to generate 2 lines of data. And you can tell source to generate 2 lines of data with 4 numbers per line. Now see, there's 1, 2, 3, 4 numbers on the first line, 1, 2, 3, 4 numbers in the second line. This way you can get just a little bit of data. For testing purposes, if you just want to generate a little bit of data, okay, so here's 3 lines with 5 numbers on a line. So there's 15 random numbers there. Okay. And then I can take those 15 random numbers and send them through the filter demo. And I can tell the filter demo to give me 6 columns that are 6 spaces wide, 4 columns, and group things in 12. Okay. So I have a lot of ideas here. I have a pipe. The pipe connects 2 programs. It connects the output of one program to the input of another program. This program generates standard output and it sends it through the pipe. This program reads from standard input, which it gets from the pipe. This program sends its output to standard output, which in this case is the console window because I haven't redirected it. These are command line arguments to this program. This program checks those command line arguments and changes its behavior depending on them. This program checks its command line arguments. And I can add one more idea to this. I can take that same example and send the output from the filter into another temp file. Okay, so I used a whole lot of ideas on this command line. A pipe, an I/O redirection, standard input, standard output, and command line arguments. Okay, and this is a big part of of how people, when people do cloud computing and they're not working with a GUI, this is what people work with. They work with these command line systems, and this is how people build up large systems to process large amounts of data. It's usually done with these pipelines. People a lot of times refer to this as a pipeline. Data starts here, goes through the pipe filter, it gets piped through the filter, then gets sent to the file. So in a sense, the pipeline starts here, goes through here, and ends here. And like if you Google you'll get a huge amount of information on what's a data pipeline. You know, that this has become the modern way of thinking about how to process data. Okay, so this is what we're seeing here is the baby version of a data pipeline. This is working on a command line, and it's the beginning idea for what we mean by data pipelines. But the data pipelines that people run, this is Amazon Web Services. Okay, Amazon Web Services is the biggest cloud service. You think Amazon sells you stuff, but actually they make even more money running computers for other people. It's a little known secret that Amazon actually makes more money running data centers for other people. I think it doesn't make half its money, but it makes a very large chunk of its money by running data centers for other people. And it's called AWS, Amazon Web Services, is their data, their cloud service for other people. And it's mostly built on data pipelines. Their cloud service is built on this idea of pipelining. Okay, so these are baby pipelines. What we're doing here are baby pipelines. So we're learning the basic of a source of data passed into something that filters the data, And then you can have more than one filter if you wanted to. For example, I could do something weird here. I could take the output of one filter and filter it again, because it's still just numbers. This won't really do anything because this data will get formatted by this program, and then it'll get reformatted by this program. So the formatting step in the middle won't really do anything. Okay. Right now, the data is being filtered 2 times. It's being filtered once by this guy, then being filtered a second time by this guy. But I actually have a pipeline that starts over here in source. The output of source is filtered through this program. Then the output of that program gets filtered through this program. And then the output of that program shows up on my console window. So if I want to, I can create arbitrarily long pipelines. Usually each stage, these are called stages of the pipeline. Each stage will do something important. Here, I'm just got the same I'm just using the same stage over again, but you can create pipelines as long as you want. Okay. All right. So now let's turn from the homework assignment to an example on the course website that's real similar to the homework assignment. Okay. There's this zip file here, homework 1 examples, that are much simpler examples structured almost exactly like the homework assignment is. So let me download this thing and we'll switch to it. From the homework assignment, we'll switch to it for a while, and then we'll come back to the homework assignment. Okay, so let me clean up here. I don't need that zip file. And we'll see, where did the new one? Oh, it's downloading real slow. We're back to like it was Monday. It's downloading really, really slow. Looks like it's stalled. Okay, I'm not going to waste time watching it stall. I'll just grab it off of my hard drive. No. Okay, I'm gonna cancel the download, and I'll just get the zip file off. Is anybody at home having trouble? Is anybody able to download it? Did it download for anybody?
I am still not able to download it.
It just
Yeah,
stalled
I did. It downloaded for me.
for you. I wonder if the server can't handle like a bunch of people downloading it at the same time. It occurred to me the other night that if all of us try to download it at the same time, maybe the server can't handle that much load. Maybe that's why it's stalling. I'm not really sure what's going on. Okay, but yeah, if that's the case, then you just wait a few minutes, and maybe if not everybody downloads it at the same time, it'll be okay. But I'm not sure what's happening with if it's the web server at school, or if it's just a funny coincidence. If it's everybody having to download at the same time, or if the web server at school is just acting slow for some reason. Okay, so here's the homework. This is that folder of examples. Okay, let me clean up some more. Too many windows open right now. This is the kind of work you need to do with two monitors. Yeah, you start ending up with a lot of windows open when you start doing these things, and it helps to have more than one monitor sometimes. Okay, so I don't need the zip file anymore. Okay, here's homework 1 examples folder. Okay, so let's look at the we played around a little bit with this folder on Monday. We just used it as an example of a program to compile. But we didn't talk about what the program did. So on Monday, we compiled this program and we talked about the compiler. Okay, so the compiler is this one. Right now, I'm just using the compiler that's came with the you download from the course website. Okay, this is the editor for it, and this is the compiler. Remember, the compiler's in this folder here. Okay, this is the compiler itself. It's that guy right there. that guy right there is the compiler, GCC, GNU C compiler. And then this is their C++ compiler, G++. Okay, right? So that's the tool we're using, but we'll use it through this editor for the most part. Okay, so if I drag that file to there, I can compile it. Okay, I can compile the program. Okay, now this program Incrementer is another filter. Okay, so here's what I'm going to do. I'm going to run it. I'm going to open a command window here. And if I run Incrementer, it's a filter program. It expects you to give it numbers. And what it does is it adds 1,000 to every number you give it. So the numbers go in, and what comes out are those numbers incremented by 1,000. Now, 1,000 is the default value. Now, I want to tell this program I have no more numbers. I type Control-Z to mean end of file. So there's no more numbers. Here's something that's important. If I run this program, now I can give it some numbers, and I want to stop the program. A lot of you would type Control-Z or Control-C. Control-C is not the same thing as Control-Z. Okay, there's a big difference between them, and it's going to be an important difference in the way we work in this class. This program's expecting input. If I type Control-C, I'm telling Windows, kill the program. And the program is terminated essentially unnaturally. If I type Control-Z, I'm telling the program there's no more input data for you. So now you can do whatever you want to do, but there's no more input data. Now, in this case, the program quits because there's no more input data. But the program may actually process the input data at that point, or it might do some other things. It might do some cleaning up. Control-Z tells a program there's no more input, so go ahead and do whatever you want to do now. Control-C kills the program. It just halts it at that wherever it is and doesn't allow the program to finish what it was doing. So a lot of programs, it doesn't matter if you Control-C or Control-Z them. Like in this case, it doesn't. But in general, there's a huge difference between Control-C and Control-Z. Control-Z, whoops, Control-Z, like here, if I type Control-C, there was no output. The program never saw the input because I typed some numbers and hit Control-C. Okay. On the other hand, if I type Control-Z, whoops, that didn't work. Yeah, I'm sorry, you can't type, now my program is kind of messed up. You can't type Control-Z at the end of a line. It's actually kind of a funny thing about Windows. When you want to type the Control-Z, it's got to be at the beginning of a line. See, that works. If you type the Control-Z at the end of a line, weird things happen. Okay, the program's now stuck in an infinite loop. Then I need the Control-C. See, this is when Control-C really useful. Control-C will kill the program that's in the infinite loop. Okay, so there you see the control. There's the Control-C. When the Control-C, like the Control-Z, they look like a little up arrow. See, I just typed Control-Z, and I type Control-Z. Windows shows you it as a little up arrow, the caret key followed by a Z. In the world of Linux and in the world of command line, we use control characters all the time. Control-Z, Control-C, Control-F. Let me show you. Let's see. See if this works. Run the incrementer. I'm going to set it into an infinite loop again. So I'm going to purposely put it in an infinite loop. Okay, it's not. So on some programs, I can type. If a program is printing out a lot of output like that, Control-S and Control-Q are supposed to stop the scrolling, but it's not working because this program is kind of messed up. But Control-S and Control-Q start and stop scrolling, but that's not working in this one. So all I can do is Control-C. See, all my Control-S's and Control-Q's weren't used. Okay, there's a bunch of control keys that you use on a command line. The two most important are Control-C for killing a program when it's not doing, when behaving right. And Control Z to mean there's no more data. So, but that's important. The Control Z just says no more data, so the program can finish what it's doing. Control C kills the program. Okay. Now, this incrementer takes a command line argument. See, now it increments by the command line argument. So instead of incrementing by its default value, now the command line argument tells it what to increment by. Okay. And if I want, here's a file of numbers. I can tell incrementer to increment the numbers in the numbers file. Okay. I use the O redirection. I say incrementer, instead of reading, now it's no longer reading from the keyboard. It's now reading from that file. Now let's look at the source code real quick. Here's where the program is in a while loop reading from standard input. The scanf function is the function. It's like the scanf is like scanner in Java. It's the generic term for reading input in a lot of programming languages, scanning. So Java calls itself, it has the thing called the scanner class. C has a function called scanf. Okay, F stands for formatted. That's these funny little characters here, the format strings. Printf is the thing that prints formatted. So print sends things to output, and it uses this little F. F says it uses these little format strings. Scanf reads and uses these little format strings. In the homework assignment, I give you links to some places on the internet where you can read about scanf, the format strings of scanf and printf, and that's in the textbooks that are part of the course reading. So that's one of the things. That's one of the things you have to start getting used to for this homework assignment, is the printf's formatting string and the scanf's formatting string. Okay, so this reads. Now, what does this read from? Well, if you read a bad C book, it'll tell you it reads from the keyboard. And if you read a bad C book, it'll tell you that this prints to the console window. If you read a good C book, it'll tell you that this reads from standard input, and this thing writes the standard output. And there's a big difference, because over here, depending on how I run the program, this scans out of that file because it's scanning from standard input. But when I run the program, I determine at runtime what standard input is. So down here, if I just call incrementer, right now, scanf by default is the keyboard. Okay. But if I run it this way, now scanf magically changes what it's doing. Scanf now is that file. I didn't have to type anything. Okay. Scanf, yeah, and this is how you can really tell real fast if you're reading a good C book or a crummy C book. Usually, if it's a freshman level C book, it'll tell you that scanf reads from the keyboard. And usually for a freshman level course, that's good enough. But it's misleading because a lot of people then think forever the scanf reads from a keyboard. And they have a hard time ever getting to the point where they realize that no, scanf reads from standard input. And you could change what standard input is. Same with printf. Almost every introductory book will tell you, like, now there's some really good even introductory books that explain standard input and standard output at the beginning. You know, and if it was me choosing what book to use, I would use one that explains standard input and standard output from the beginning, because I think it's really misleading to tell people that printf prints to the console window. It prints to standard output. So, for example, over here, if I run this line and I say, oh, but now, okay, now incrementer ran, scanf was tied to that file, and printf was tied to that file. And in my folder now, there's that file temp. See, that's the output. That's the output that the incrementer produced. Okay. Now, the incrementer can be given a command line option. Okay, 7. Now it's incrementing by 7. Okay, how does that work? Let's look inside the code. Your program gets command line arguments there. argc is the count of how many arguments are on the command line after the name of the program. Oops. For example, right now, this program has 1, 2, 3, 4 command line arguments, except in C and Java differ here. This argc counts the word incrementer as 1 argument. So if I were to run this program like this, the variable argc would be 1, 2, 3, 4, 5. It counts how many tokens there are on the command line. So there's the 6, the 5, the 4, the 7, and the word incrementer. So that's 1, 2, 3, 4, 5 tokens separated by spaces on the command line. So argc would be 5 here. Okay. Then this is an array of strings. The first string will be incrementer. The second string will be the string, not the number, the string 7. The next element of this array will be the string 4. Then the next element will be the string 5. And the next element will be the string 6. If I make this okay, now argc will be 1, 2, 3, 4. Okay, this array of strings, this is the way C says array of strings. It's an array, that's the closed brackets. A string is a pointer to a character, because what you do is you point at the first character of the string. So a string is in C language a pointer to a character. So this is an array of pointers to strings. The first string will be the word incrementer. The second string will be the string 700, not the number 700. You have to use a special function to convert this, just like in Java, you have to convert the string to a number. So the second command line argument will be the string 700. The third command line argument will be the string 500, and the fourth command line argument will be the string 2000. Okay, so incrementer will notice what incrementer does is here it checks, is there a command line argument? See, if I run incrementer like this, there was no command line argument. Well, there was one command line argument, the name of the program. So there wasn't a second command line argument. So if argc is strictly greater than 1, there are some command line arguments. Okay, so if I do this, now argc is 2. There's 1, 2 command line arguments. So I get to this if statement. argc is 2, so argc is greater than 1. There might be more than one command line argument. I'm only going to look at the first one. Here is the first. Now I'm using this array. I'm getting index 0 is the word incrementer. I don't care about it. Index 0 is the word incrementer. I want the second word in the argument array. So that's my number. And then this function here converts it to an integer. A2I stands for, now this is old-fashioned C stuff. This is in the day when nobody wanted to type out anything, as opposed to the Java language where everybody types out everything. A stands for ASCII, I stands for integer. This is the function that converts ASCII strings to integer values. So it's called A2I. It converts ASCII strings to integer values. Okay. There's a function just like this in Java. it's called parse int. It parses integer strings and gives you integer values. Here it's called A2I. Okay. Now, in the homework assignment, I give you links to where this stuff, you can get information about this stuff. If you just Google A2I, you'll get a nice explanation of it. This is the A2I function in the C language. This is a very nice website. This website, you can look up all kinds of functions in it, and they give you examples of code. They explain how the function works. They give you, like, here's a little example using the A2I function. They give you other functions that are related to it that are similar. Okay, it's a very, very good website. This is like JavaDoc. You know, Java has its JavaDoc. JavaDoc is the official documentation of Java. This is not the official documentation of C. There is no real official documentation for C, but this is a well-done website. Okay, so if you Google, like if I go back over here and I Google printf, see, I get their reference on printf. Okay, here's all the information about those format strings. Okay, if I go here and I Google scanf, scanf, see, it's not the first link. Their reference is the second link. There's their reference on scanf. Here's more format strings. Here's scanf's format strings. Okay, we'll say a little bit more about those as we go along. Okay, so now, like any language, you learn a language by reading people's code and looking up the functions they use. Okay, that's how you learn a language. You read people's code and you look up what is it there. You know, if you see them using this function, you look it up. If it's a Java function, you look it up in the JavaDoc. If it's a C function, you look it up on that C++ website. And you learn by seeing what they do with the function and then reading about the documentation. Okay, all right. Now, again, over here, see, after I convert that input string to an integer, I store it in this variable. Now, originally, this variable was, that's my incrementing increment. I thought I incremented by 1,000. Did I miss? Oh, okay. Notice that the default value for incrementing is 0. But then that incremented by 1,000. But the default value is increment by 0. What's going on? Where did the 1,000 come from? The command line argument, we just saw where the command line argument. So here's the default increment by. Down here is where it gets the command line argument. But before it goes to the command line, it checks for two other things we want to talk about. This program has a configuration file. I called it incrementer.config. Configuration files are ubiquitous in computer science. Programs, especially like big programs like web servers and database servers, they'll have a file somewhere in the hard drive that sets all the parameters for how the program works. Okay. This config file is real simple. It holds one number. It says incrementer should increment by that number there. Okay. So what incrementer does is that when it starts up, incrementer says, is there a configuration file for me to read? So it tries to open this file incrementer.config. If this file doesn't exist, see, I'll change its name. Okay, now I changed the name of the file. Oh, I have it open in the edit. Let's see, where do I have it open? Do I? Oh, it's open in this program. This program was using it. There. So I changed the name of that file. Okay. Now if I run incrementer, it increments by 0. So the flow of the program was now, the program sets incrementer to its default value of 0. It asks, can I open the file incrementer.config? And Windows looks in the folder and says, there's no file called incrementer.config. So this function returns null, and this if statement drops out. On the other hand, if the file is there, this function will return a file pointer that's not null, and then I can use the file scan function to read from the file pointer an integer. Okay, there's a lot going on there. Okay, and in the homework assignment, there are references to where you can read about this in C books. Okay, right now I'm just kind of describing it in words, and you'll want to, like, well, for example, I can go here and say, well, F scan F. There's the F scan F function. Scan means read. This F means using a format string, and this F means from a file. So this is file scanning formatted. Scanf, which is almost the same thing. Oops. This scans formatted from standard input, not from a file. So these are actually pretty much the same thing, just that this one defaults to reading from standard input. This one reads from whatever file you tell it to read from. This one specifically reads from a file. This one reads from standard input. Now remember, standard input might be a file. If I've redirected standard input, then this thing will be actually reading from a file, but it doesn't know that. It reads from standard input, and it doesn't care what standard input really is. It might be the keyboard, it might be a file, it might be an internet connection. You can even make standard input an internet connection. So this thing reads from standard input. See, it says it right here. Read, formatted. Read is the scan part. Formatted is this little F here. And this one's from standard input. Whereas this one is read, that's the scan part. Scan is like an old-fashioned word for read. Formatted is this F here, from a stream. That's the technical word for files. In Unix and C, we usually refer to files as streams. And in this homework assignment, I call these, I call this a stream of numbers. It's just one number after another number after another number after another number. That we think of that as a stream. Like a file is just a stream of characters or a stream of numbers, one after another after another. So in the world of C and Linux and Unix, they refer to them as streams. Okay, and data streams and data pipelines are very, 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 you process data streams in data pipelines. Okay, so this is what like this. Look at the second link I got. Snowflake. Snowflake is a multi-billion-dollar company that just started a couple years ago to process data online. It's not a company you're likely to have heard about, but if you're in Silicon Valley, you hear a lot about Snowflake. It's worth, I don't know, $50 billion or so right now. It's only a couple years old, and its whole reason for existing is to stream big data. Okay, so it's a company built around data pipelines of streaming data. We're doing baby streaming here. We're doing baby streams, but the idea is the same. A stream is a stream. If my stream here is 100 numbers long, Google streams are a couple billion numbers long. And those streams would be things like mouse clicks, orders, just streams of data, just massive streams of data. But it's still the same idea. The stream here and the stream here, the stream here and the stream here are really the same idea. Okay, data streams. And it doesn't matter if it's a little bit of data, like what's in a file, or a huge amount of data like you get off of the internet. You process these streams through these pipelines. So what we're talking about is the baby beginning of these ideas. Okay, so fscanf reads a stream that's in a file. Scanf reads a stream from standard input. But standard input could be the keyboard, or it could be the file, or it could be an internet connection. Okay, all right. So now my program, back to my program, the first thing the program does is it set the default value for incrementer. Okay. Now in your homework assignment, you have 3 parameters, not just one. You have the width of the columns, the length of a group, and the number of columns. So your program will start by setting the default value for those 3 parameters. Then your program, your homework assignment is going to do just like this does. It's going to check for a configuration file. And if there's a configuration file, it'll replace the default value with what's in the configuration file. Then after it's checked for configuration file, you're going to check for something called an environment variable. Okay. Okay. Here's a really strange idea. This is actually, it's not a strange idea. It's an idea you haven't probably seen before, but it's an idea that gets used, like a lot of this stuff. I'm trying to introduce you to things that actually get used a lot in the real world, but they don't get taught much in courses. Windows has variables. Windows is almost like a little baby. This console window is like a baby programming environment. See, I can type commands there and they do things. Yeah, I can type the dir command and it tells me what's in my current directory. Oops. If I type the dir command, it tells me what's in my current directory. If I type the date command, it tells me what the current date is and it lets me change it, but I don't want to change it, so I just hit enter. Okay, I can type commands. I can type ns lookup and I can get the IP address of Google. Okay, so I can run commands. Okay, this is a baby programming language. On Linux, this baby language at the command prompt is called bash. This language is called CMD. Okay, it has variables. And if I type set, I see all the variables this environment has. It has a bunch of built-in variables. When I type set, I see the name of the variable and its value. So for example, there's a variable called WinDir that keeps track of where the Windows folder is. On my computer, the WinDir is the C:/Windows folder. It keeps track of things like what's my system drive. Almost everybody's system drive is the C drive, but sometimes people set up their computers differently. They might have a system drive that's the B drive or the E drive. This thing determines my prompt that I see when at the blinking cursor. I can change that prompt variable. I can say set prompt equal to, I'll make it $T. I changed my prompt. My prompt is now if I do set, you'll see that the prompt variable changed. The prompt variable now is $T. My prompt is time, the current time. Now, I think that was not a very good prompt. I'm going to make it time, then $, I think it was, no, oh, there, that's a little bit better looking. So now my prompt is time with a little arrow next to it. Okay, so I set that variable. Okay, these are called environment variables. You can set them and you can use them. But you just saw me set the prompt variable. I changed that variable and that changes my prompt. Okay, I'm going to set an increment value. Now let me check my program. I think that's how I spelled it in the program. Oh no, incrementer value. I changed. My program asks, is there a variable with that name in the environment? Has somebody set that variable? And if somebody set that variable, it's a string, and it takes that string and it converts it to an integer and uses that as the incrementer. Okay, so I'm going to set the incrementer value equal to 22. Now I'm going to run incrementer, and it increments by, whoops, did I spell that right?
You missed the N in incrementer.
Oh, yeah, I'm sorry. So let me reset. Okay. Here's how I get rid of the bad value. You set it equal to nothing. That erases that value. And then I'm going to spell it right. See, now I'm incrementing by 23. I'm incrementing by 22. So what did my program do? It started up, set the increment value to 0, checked for a configuration file. If the configuration file is there, it will use what values in it. But then it uses the environment variable to make a change. So the environment variable overrides anything that was in the configuration file. The order here matters. There's the built-in value. Then the next level would be what's in the configuration file. Then the next level is what's in a environment variable. Then the command line arguments look for. So for example, if I go back over here and I change the name of the, okay. Right now, there is a configuration file. There is an environment variable. If I run Incrementer, it's going to open the configuration file, get the value out of it. Then it's going to find the environment variable, get the value of it. But then if I put a command line argument, it's going to find the command line argument. It's going to increment by the last one it looks for is the command line argument. The order, this is standard in Unix world. Programs look for a configuration file. Well, programs set default values for all their parameters. So any program that runs on Windows or Unix, it'll set its default values inside the program. Then it'll look for a configuration file, use those values to override the default value. Then it'll look for environment variables, use the environment variables to override what was in the config file. Then it'll look for command line arguments and use those to override what was in the environment. This is a system that's been developed over many years to make it easy for people to configure and run programs. Okay, it's a standard way to configure databases, web servers. Even Chrome uses this. Your Chrome browser does this. Visual Studio does this. Visual Studio has a config file and has a whole bunch of environment variables that it uses. And you can configure Visual Studio by editing its configuration file and by editing its environment variables. Most people don't do that. Most people use the GUI to make changes in Visual Studio. But if you wanted to, you can sort of make the changes semi-permanent by editing environment variables and configuration files. So your homework assignment is going to have the same outline. Your homework assignment is going to set 3 parameters into default values. It's going to look for a configuration file, and if it finds it, it's going to get 3 values out of the configuration file. Then it's going to look for 3 different environment variables, and then it's going to look for command line arguments. Then it drops into the loop that's the real filter. Read from standard input, write to standard output. Read from standard input, write to standard output. Okay. Notice that there's the loop, there's the little loop, and your program will have your program, your homework assignment, the loop will be a little bit more complicated because when it reads another for standard input, it's got to put it in the right column and check if it's got to the end of a column, it needs to start a new line. So there'll be a little bit more work to do in the loop. So there'll be code to set the parameters, default, config file, environment variable, command line arguments. Then you drop into the loop that processes the input data and produces the output data. Okay, so this is the outline of your homework assignment. Okay, you can actually take this and modify it into the homework assignment. And this would be a good place for you to start. You could start with this file and just start adding to it. It needs more initial values, and you got to give them good name. Like IncBy is not going to be a good name, but you need initial value. You need some 3 parameters that and give them their initial values. Then the config, in the homework assignment, I tell you what the name of the config file is. You got to make sure you use the right name for the config file. So you'll open the config file if it exists. See, this is the way you open a file if it exists. If it doesn't exist, you just skip over the if statement. If it does exist, you open it and you can fscanf values from it. Okay, you'll fscanf 3 values from the config file in the homework assignment. Then after processing the config file, you'll need 3 if statements like this. This one says, this is sort of like what's here. This says open the config file if it exists. This says get the environment variable if it exists. See, it may not exist. If the environment variable doesn't exist, this thing returns null and you skip over it. So you'll need 3 if statements. You'll need to check for 3 different environment variables. Doesn't matter what order you check them in, but you need to check for 3 different environment variables. You open the increment, you open the config file once and get 3 values out of it. You need to check for 3 different environment variables. So you'll call getENV 3 times, once for each environment variable. And then each environment variable will let you override one of the parameters. Then you'll have to do some tests on the number of command line arguments. And if there's 1 command line argument, it overrides 1 parameter. If there's 2 command line arguments, you're overriding 2 parameters. And if there's 3 command line arguments, you're going to be overriding all 3 parameters. Then after you check for the command line argument, then you'll write this final loop that reads from standard input. That's the scanf, read from standard input and output the standard output. That's the printf. Okay. So this incrementer program is a good example of the kind of what your homework assignment is like. And then there's a program in here called number source, which is like the source of data in the homework assignment. It just produces a bunch of numbers. So it's a real simple program that's just meant to, so you don't, if you don't want it, if you want, you can use the pipe idea here. Okay, so I can take source and pipe it into incrementer. Oh, it's I'm sorry, it's called number source. Take number source and pipe it into incrementer. Okay, so number source just generated some numbers and incrementer incremented them. Notice that in Windows, you don't have to type the .exe. If you want, you can, when you want to run a program, you don't have to type the name. You can type just the name without the exe at the end. On the command line, you can just type like number source pipe into incrementer. If you use Linux or Mac, they never put the .exe on these files. So for example, if you go back to the homework folder, here's the Windows demo program. That's the Linux Mac demo program. See, it doesn't have the .exe at the end. In a Mac and Windows world, it's traditional not to put .exe on. Now, if I open that file, see this, see, it looks like gibberish, right? But see at the first beginning, it says ELF. That's the name of a Linux program. ELF, oh, let's see, they're called ELF files. I forget what ELF stands for now. They're called ELF files. If I open the exe program for Windows, it also looks like gibberish. Okay, but notice it begins with the letters MZ. That tells you it's a Windows executable file. Okay, see the first 2 characters here are the first 3 characters here are ELF. That tells you it's a Linux executable file. And this starts with MZ, which tells you it's a Windows executable file. But they look like gibberish because they're binary files. They're not text files. Okay, so I compiled the demo program for Linux and Mac, and that's so on Windows, when you want to run a program, you don't have to type the name exe. You can type exe or not. It'll run the executable for you. On Linux machines, tradition is you don't put .exe after the name of an executable file. It's just the name of the file with no extension. Okay, so there's the Linux version of the demo program. Okay, and I don't, the source program, I gave you just only the source code to it. I didn't give you the, I remember I compiled this here. So if you have a Mac, you need to compile this yourself. So you would compile source to get a program you could run, but I give you the demo version ready to run on a Linux or a Macintosh. Okay. All right, let's see. Got a few more minutes. Let's look at another example. There's something here called adder example. Very similar idea. Okay. A program that gets its parameters from several different places. Okay. So this program, it adds two numbers. Well, actually, let me compile it. And let me open a command window here. Okay. If I run adder, it wants me to give it two numbers. Whoops. Oh. Okay. See, if I give it two numbers on its command line, it adds them together. Okay. If I give it only one number on the command line, it adds that number to its default value, which is 100. So it's got a notion of a default value of 100. So if I give it one number on the command line, it'll add it to 100. If I don't give it anything on the command line, it adds two default values, 100 and 10. So it adds 100 to 10. So its two default values are, it's got a, well, actually, no, that's not right. Its default values are 0, 0, but it's got a config file right now. So what it's doing is it's reading two numbers, it's adding what's in the config file. Okay, so what this program does, okay, let me change the name of the config file. So there's no config file now. So if I type adder, it adds 0 plus 0. Okay, that's adding, see, there was nothing, there's no config file, there's no command line arguments. So it adds its two default values. Okay. And it also looks for an environment variable. So for example, the environment variable is called adder opt1. So I'll go over here and I'll say set adder. How do I spell it? If I want to make sure I spell it right, I will copy and paste it there. I'll set that equal to 44. Okay. Now adder adds 44 to 0. Okay. If I give it one number here, it adds 44 to 1. So now it's adding what's in an environment variable to what's on the command line. Okay. If I give it two command line options, it'll not use the environment variable and it'll use the two command line options. Okay. So it's a similar kind of idea. The program starts up, sets two default values, x1 and x2, looks for a config file. If it finds the config file, now what this does, if there's one number in the config file, it reads one number. If there's two numbers in the config file, it reads two numbers. So there's a little bit of logic here. It's going to check if the config file exists. If the config file does exist, it scans one number. And then if the scanner returned a count of 1, then it scans for a second number. Okay, so this is a little bit of a tricky thing. The scanner, it's going to check, it's going to read one number and check if there's a second number. So it reads one number if there is, if there isn't a, It reads one number if there's one number, and it reads two numbers if there's two. And actually, you can have an empty config file, and it'll open the empty config file and won't read anything out of it. So this will also work if the config file is there, but the config file happens to be empty. So you could go here and you could take that config file and make it exist but be empty, and this loop will try to read numbers from it, and it'll just get zero. No, it won't read any values from the config file. It'll just see end of file right away. Okay, so it reads one or two numbers from the config file. Then it looks for one operand for the x1 in an environment variable. Then it looks for a second operand for x2 in another environment variable. Then it looks for command line arguments. It looks for a first command line argument, looks for a second command line argument. Then after it's checked for all those values, it adds the two numbers. So that number could be the default number. It could be what came out of the config file. It could be came out of an environment variable, or it could be coming from the command line. Same with this. It could be the default value, what it found in the config file, what it found in the environment variable, or what it found on the command line. Okay, so it's another example of how your homework assignment is going to work. This one's a little bit, this one shows you checking two environment variables, checking two different command line arguments. And actually it shows you don't need to do this in the homework assignment. In the homework assignment, you'll always read exactly three values from the config file. I did that to make it easier. So that in the homework assignment, if the config file exists, it's guaranteed to have three values in it. Here, this is what it looks like when the config file might exist, but it might have 0, 1, or 2 values in it. So you have to write a little bit more logic to read either no numbers, one number, or two number from the. If the config file doesn't exist, you skip over this. But if the config file does exist, it could hold 0, 1, or 2 numbers. Okay, so you have several examples here to look at, several examples of code to look at. Remember, on the homework, if you go back to the website, that's this folder here, homework 1 examples. Okay, so homework 1 examples folder has the good examples, the outlines of what you need to do for the homework assignment. Okay, we're out of time. Anybody have any question?
Yes, I have a question, Professor.
Sure.
For the first homework, I already read the first 6 pages of the reading assignment. Is there another thing we should read to do the homework, or?
Yes, well, there's a lot of little things you should read for the homework assignment. The homework assignment has links in it to lots of ideas, like what's a filter program? Yeah, what's a stream? You might want to glance. Some of those are just a little bit interesting to look at, but what you really need to read is you need to read about printf, format strings, fopen, the functions you're going to use. You have to be familiar with these functions. Okay.
All right. So basically, read all that, and we should
Yeah.
be able to
Yeah, and when you look at the example programs in the example folder, you'll see it using these functions, and you'll be using these functions in similar ways, but you need to know a little bit more detail about them. So fopen, scanf, a2i, like for example, command line arguments. Here is a chapter from a book on command line arguments. Okay, so you want to read this. So it's just 2 pages long. And then here's another book with takes a little while to load, couple pages about command line arguments. This one always loads real slowly.
No worries.
But yeah, see, user input. So it's a short chapter on user input. Talks about scanf, talk about command line arguments, reading command line arguments. So there's pointers in the homework assignment to where you can get information that you're probably going to need. The information's scattered around. There's no one nice website or reference I can point you to and say, read exactly these 5 pages. The information is, and this is just the way the world works, the information is going to be scattered all over the place. Down at the bottom of this assignment is a list of the functions you need. So there's a summary of all the functions you'll need. And I just pointed you to 3 different sources of information. Like there's the printf function described 3 different ways. There's the scanf function described 3 different ways. Some people like one source of information, some people like the other. So, no one of these is the best one. Okay, so yeah, there's a lot. You'll need to read a lot of little things. Okay. Hey, other questions about the homework? Or actually, you'll come up with questions as you look at this stuff. So as questions come up, send me emails, or oh, we don't have class on Monday. Okay, so we won't meet again till next Wednesday. But if you have questions, then we can talk about this again a little bit at the beginning of class on next Wednesday. Okay, this is not a long assignment to write, but it's a lot to read. You're not going to write a whole lot of code, but you're going to be using a lot of ideas that none of them are hard ideas, but a lot of ideas that you've probably never seen before. Don't wait till the last minute to start this. You will not be able to write this in one evening. I absolutely guarantee you that no one can write this in one evening. Okay, it's not a lot of code. You're only going to write things about 50 lines altogether to finish this, but a lot of ideas. So start reading about it and trying, working on it as you work on it step by step. Actually, I'll show you one last thing. Here's a little outline of how I suggest you work on this. Build this program in steps. Sometimes people call that incremental development. Okay, you build the program little bit at a time. You don't write 50 lines of code and then hit the compile button. That won't work very well. You want to write 10 lines of code and get it working, write 10 or 15 more lines of code, get it working, write 10 or 15 more lines of code, get it working. So here's a little outline of steps you might try. Okay, well, okay, we'll quit there. We've gone over a little bit. Any last question? Anybody got any last question at all?
Yes, I have a question.
Sure.
Is it possible to speak to you after class?
Sure.
Okay, thank you.
Send me a Zoom link, okay? Can you
Should I
send me-
create my own meeting or?
Well, how do you want it? Yeah, I mean, you can, yeah, send me a Zoom link and we'll meet in a little meeting. That'd be the easiest way to do it.
Okay.
Because just send me a Zoom link.
Should I just put it in the chat or
No, send it to me by email.
by email?
Yeah. Okay.
Do we use the office hour Zoom? Is that possible?
I don't even know. I don't even know if you can. That's set up for a certain time. I'm not that great. I mean, I don't really know a whole lot about Zoom. Try it. Yeah, you can try clicking on the office hour link. I'm not sure what'll happen, because usually I start the office hour meeting ahead of time and then people join it. But
Okay.
it's set for a certain time. You can either create a meeting on your own and send me a link to the meeting, or you can try clicking on that office hour link.
Okay.
All right.
I'll try both of them and I'll
Okay.
just email you whichever Zoom link I.
Okay.
Okay, thank you.
Okay. Anything else? Okay, so I'll end. I'm going to stop sharing and I'll end the meeting now. Okay, have a nice weekend. See you a week from today. Bye.
Thank you.